Hello everyone, very good evening one and all. Welcome to BYJU'S exam prep and welcome to the session. All dear friends, all dear NIELIT aspirants, join the session quickly and mark your presence. Please confirm, am I visible and audible to you clearly or not? Today, let us have mini mock test on computer networks. Hi Satya, good evening. Please confirm my visibility and audibility, everybody. Hello Shiv. Okay. Right. So guys, BYJU'S exam prep conducting the national scholarship test through which you can avail up to 90% off on all our programs, and the upcoming scholarship test is there on 22nd October. So register for this and avail the benefit. And there is a live interactive workshop by Richa Gupta madam on 25th October. In this workshop, madam will speak about the detailed preparation strategy to ACE GATE 2025. So it is going to be very useful workshop for 2025 aspirants. So if you are so, please do register for this. Okay. And this is what the complete schedule of All India Open Mock Test for 2024 aspirants. And this is already live on 14th October and till 20th October. That means till today, this would be live. So if you have not registered, please do register. And guys, there is a crash course for GATE 2024 aspirants. In this, live classes, recorded lectures, study material, practice quizzes, mock tests. So it's a complete packed course. So do enroll for this 2024 crash course, and also for 2025 and 2026 aspirants, the admissions are open. So do enroll them. So this is quick introduction about me. If anybody are new for my class, you can find my quick details here. Okay. Shiv, it's not happened. Yesterday I could not take the class on some personal issue. That's why you can't see that in the playlist. Okay. No issue. So here is the first question, guys. Which of the below statements is incorrect regarding email protocols? Manishankar Tiwari, hi, good evening. How are you doing? Yes. Options: SMTP is message transfer protocol and POP IMAP are message access protocols. While X sends an email to Y, SMTP is used twice. IMAP is preferred over POP to retrieve email, as IMAP can authenticate mails to be received. While X sends an email to Y, SMTP is used only once. So which of the below statement is incorrect? Right. While X sends an email to Y, X will send to the X server, X mail server. The email is dumped. From X mail server to Y mail server, then the email will be transferred. From Y mail server, Y will retrieve. Here, POP IMAP will come into picture, while here SMTP will come into picture. So SMTP is used twice, not once. Hence, option D is incorrect. So answer is option D. Okay. Question number 2. Consider an instance of TCP's AIMD algorithm with segment size as 200 bytes and advertised window size as 2000 bytes. After fourth transmission, if sender received one acknowledgement only, then how many bytes sender will prepare to send to receiver? Options: 1020, 1040, 2080, 4160. One MSS is given as 200 bytes. Advertised window size is 2000 bytes. Hence, you can say threshold would be half of that. That is 1000 bytes would be the threshold. Right? So, in the AIMD algorithm, first slow start phase will start, which will send first one segment, that is 200 bytes. After receiving an acknowledgement, to that one more is added. So, in the second attempt, sender will send 2 MSS. After receiving these 2 acknowledgements, sender will send 4 segments. Means 800 bytes sender would be sending in the third attempt. Now, in the fourth attempt, sender will send 8 segments. But how he will send? How he will send? Do he send 8 segments at a time? No, he cannot. Why? Because the threshold is only 1000 bytes. So, what sender do? What sender do? Sender will send only 5 segments. That is what 1000 bytes, which is the threshold. Now, 5 segments means sender is waiting for 5 acknowledgements. Whenever threshold reaches, additive increase phase will start. So, if sender receives all the 5 acknowledgements, in the next attempt, sender would be sending 6 MSS. But given after 4th transmission, sender received only 1 acknowledgement. So, 5 acknowledgements, sender will add 200 more bytes, but only 1 acknowledgement. So, sender would add 200 by 5. So, 1000 plus 200 by 5, that is 1040 bytes sender would be preparing to send after 4th transmission. So, it is 1040. Okay? You understand? Everybody? Yeah. Question number 3. Consider an instance of transport layer AIMD algorithm for congestion control. Look at this question, read the options. If sender received 3 consecutive duplicate acknowledgements before the timer expires, then it indicates that network has heavy congestion, receiver did not receive any of the packets sent by the sender. Network has moderate congestion, receiver did not receive any of the packets sent by the sender. Network has heavy congestion, receiver received 3 packets sent by the sender after the last packet, and network has moderate congestion, receiver received 3 packets sent by the sender after 1 lost packet. So, what is your answer for this question? Question number 3. Yep. Whenever 3 duplicate acknowledgements, that indicates moderate congestion, not heavy congestion. When the timeout, that is heavy congestion. So moderate congestion should be the answer. So here you can actually eliminate 2 options. Now, 3 duplicate acknowledgements means sender, receiver, let's say you have sent 4 is lost, 4th segment, then you have sent 5, 6, 7 also, but receiver received 5, 6, 7, but receiver would be sending the acknowledgement of what? That 4th segment starting sequence number only 3 times. So 3 duplicate acknowledgements, one by receiving 5th, one by receiving 6th, one by receiving 7th. So receiver received 3 packets sent by the sender after 1 lost packet. So the right answer is option D. Yeah, yes, respect me. I'll teach operating systems. Okay. Question number 4. Consider a network that uses Hamming code for error control. If received code word is so and so, while sent code word as C1, the receiver could realize that C2 contain an error at 9th position, C2 contain an error at 6th position, C2 contain an error at 11th position, C2 equal to C1 means no error occurred. Shiv says option D. Okay. What about others? Let's solve it. So we are given 1 1 0 0 0 0 1 1 0 1 0 1 0 1. So now I am writing the positions 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So receiver would be calculating the code words, this check bits C1 dash, that is 1 XOR 3 XOR 5 XOR 7 XOR 9 XOR 11 XOR 13th position bits. So they are equal to 1, 3rd position 1, 5th position 1, 7th position 1, 9th position 0, 11th position 0, 13th position 1. How many ones? 1, 2, 3, 4, 5. Odd number of ones. So C1 dash is 1. So here itself it is understood there is an error. What about C2 dash? C2 dash is 2 XOR 3, then leave 2. 6 XOR 7, again leave 2. 8, 9 you leave. 10 XOR 11, again you leave 2. 12, 13, XOR 14. So these position bits we have to do XOR. So second position 0, third position 1, sixth position 0, seventh position 1, 10th position 0, 11th position 0, 14th position 1. 1, 2, 3 ones, odd number of ones. So 1. Now C3 dash, which is include 4, exclude 4. So 4, 5, 6, 7, then exclude 8, 9, 10, 11, 12, 13, 14. So 4, 5, 6, 7 are 0, 1, 0, 1, and then 0, 1, 1. So even number of ones, so 0. Now finally C4 dash, that is include 8, exclude 8 starting from 8. So 8, 9, 10, 11, 12, 13, 14. 8, 1, 0, 0, 0, 0, 1, 1. So 1, 2, 3 ones, odd number of ones, so 1. So always error is at C1 dash, C2 dash, C3 dash, C4 dash at this position, which is 1, 0, 1, 1. So 1, 0, 1, 1 is 11th position. So the error is at 11th position. Okay. Am I clear? Question number 5. Match the following. On the left we have protocols, on the right protocols or parameters, messages we have, and on the right when such message is returned. ICMP error messages we have, protocol ARP, RARP we have. So match the following. Quick. Address resolution protocol from IP to find MAC. Reverse address resolution protocol from MAC to IP. So FE. ICMP destination unreachable. Router failed to identify the destination address. So FED. Source quench. Time exceeded parameter problem. Here actually you can easily find time exceeded means 5 would be B. So all have 5B. Now parameter problem 6A. So only one option is there. Unable to find. Source quench means buffer is full. Question number 6. Consider the data transmission from station A to station B with the following information. Sliding window protocol, stop and wait, bandwidth, propagation delay, frame size given. What is maximum achievable throughput? 4 kbps, 6 kbps, 8 kbps, 10 kbps. First of all, utilization must be 100%. So 1 by 1 plus 2a. Transmission delay is frame size by bandwidth, that is 800 bits divided by 8 kilobits per second. So this is 100 by 1000, 0.1 seconds. Or else I can say 10 milliseconds, 10 into 1000, 10 by 1000, no, 100 milliseconds, yes, right, 100 milliseconds I can say. Now A is equal to propagation delay by transmission delay, that is 100 by 50 by 100 1 by 2. Now u is equal to 1 by 1 plus 2 into 1 by 2. So this is 1 by 2, 50%. So maximum throughput is utilization multiplied by bandwidth. That is 1 by 2 of 8 kbps, which is 4 kbps. Option A is the right answer. Okay. Question number 7. Consider an IP datagram with header prefix so and so. The payload present in the datagram is dash bytes. Header prefix is 4E7B 63EA, so on. Here this is version. E is HLEN. This is type of service, right? And this is total length. So now 63EA, which is in hexa, convert to decimal. This is A into 16 power 0 plus E into 16 power 1 plus 3 into 16 square plus 6 into 16 cube. So you can use the calculator. I am also using the calculator, dear friends. 16 into 16 into 16 into 6. So this is 24,576 plus 256 into 3, 768 plus 16 into 14, 224 plus 1. No, not 1, 10. So 224 plus 10 plus 768 plus 24576. So altogether it is 25578 bytes. This is the total length. We know total length is header length minus payload length. So I want payload length, header length minus, total length minus HLEN value is E, that is 14, 14 into 4. So that is 25578 minus 56. 25522. So the payload length is 25522 bytes. Yes, of course. These are all easy questions, Gurumurthy. NIELIT level questions. Okay. Right. Question number 8 on your screen. Read the question carefully and give your answer. Yes, 62 hosts. Subnet mask is given as 255.255.255.192. Right? Here, host bits would be zeros in the subnet mask. So here 255 means you see 255.255.255.192 I can write like this. So however, these are all ones. So these are zeros. So 6 zeros we have. So number of hosts per subnet would be equal to 2 power 6 minus 2, because the first and last we will exclude. So this is 62. 62 is the right answer. Very good, very good. Question number 9. The broadcast address of the network 196.140.130.110/27 is dash. The broadcast address of the network so and so is dash. Come on guys, good going. Everybody giving answers correctly. Very good, keep it up. Here 27 means 32 minus 27 bits zeros. This is what host portion, right? But the broadcast address means these 5 LSB bits must be ones. So 196.140.130, 5 LSB bits must be ones and previous bits should be as it is. So what is 110? 110 is 96, 8, 106. I think this is 110. So here last 5 bits represent host ID. So these 5 can change. So remaining 0, 1, 1 will be as it is. So this is 196.140.130.127. So this is the DBA or broadcast address. Option D is the right answer. Option D should be the right answer. Okay. If it is last host address, it should be 126. Okay. All right. Last question of the day. In a packet switching network, packets are routed from source to destination along a single path having 2 intermediate nodes. If the message size is 24 bytes and each packet contains header of 3 bytes, then the optimum packet size is dash. Come on guys. See, optimum packet size means number of packets must be less. So when the number of packets is minimum, that can be optimal packet size. Suppose you take packet size as 4 to send 24 bytes message with a header 3 bytes, always 3 bytes header. How many bytes of payload you can have if you choose 1 byte of payload? That means 24 packets you have to send. Here 3 bytes of payload, that means 8 packets you have to send for 24 bytes. And if you take 7, 4 bytes of payload in every packet you can have. So for 24 by 4, 6 packets you are supposed to send. And if you choose 9, 6 bytes you can have, and you have to send 4 packets. So which is minimum? 4 packets is minimum. Hence the answer is option D, 9. Okay. How many questions you have given correct out of 10? So guys, this is what all, of course, this yesterday class was not happened, except that all the other classes that we have taken, you can see. So if you have missed any, please find them in the playlist. Okay. These are my Insta and Telegram group links. Please do join if you have not joined yet. And yes, tomorrow I'll share all the PDFs, dear friends. Thank you for joining and wish you all the very best. Keep liking the session, sharing, and subscribe to our BYJU'S exam prep YouTube channel and enable the notifications. Thank you guys. See you in the next session. Till then, have a great time. Take care. Good night, everybody. Jai Hind.